So, welcome to our first chapter, basic concepts, or more or less a warm up into the world of telecommunications. So, what is the content of this chapter? Well, basic concepts, what is a network made of? So, what are the components? What are the basic ideas of communication? And then we all know, well, we have many participants in a network. How do we share it? So, and then, sure, the main focus of this course is on the internet. So, what is the internet in a nutshell? And then we need some, well, things to create the internet, to create a communication system. And this could be quite complicated. And over many, many, many years, many engineers developed ideas of layerings, of standards, of different protocols. Why do we need this? Can we live without standards, without protocols and layering? Can we just implement a communication system? We'll discuss this. And then in the end, well, we do not just want to transfer a single bit from A to B, but maybe in the end we want to have an application that offers a certain quality. How do we describe the quality of this communication service? Okay, so but in the very beginning, let's start with what is a network made of? So what are the basic components? Well, okay, let's try to keep it very simple. So these are our main components. Okay, so what is this? So basically, we have certain nodes communicating. So these are our green circles, so our nodes here, and they want to communicate. Okay, sometimes we call them end systems, sometimes we call them hosts. This might be your mobile phone, this may be a PC, a desktop computer, this may be a huge mainframe supercomputer in a compute center. Maybe this is also a cloud computing, grid, whatever system. We'll discuss this. Okay, that's one of the components, so end systems. Then we need connections, wires, many wires, or maybe it works with a wireless system like a mobile phone system, cellular phone system, or a wireless LAN system. We need also connections between our third component. These are our internetworking units. We will see we have different types of units interconnecting networks or connecting fiber optic, copper wires, or wireless systems. So we have our end systems, we have many cables, wires, wireless systems, and we have some systems in between. We will learn different types of these intermediate systems. But first of all, let's focus on end systems. So end systems, this is what you hold in your hand. This is where we have millions, billions of these systems. We briefly touched in the introduction the Internet of Things, for example. There we have billions of things. We have some billion people carrying their mobile phones. Then we have some desktop systems and we have some mainframe, huge computers. But we have really billions of things communicating. So machines talking to machines. So those end systems, they pretty much vary in size, in their usage. So you have gaming computers, you have some smartphones, but you also have things like simple controllers. Well, simple, maybe sometimes they are a bit more complex, but controllers controlling your heating system, your HVAC system, your whatever. So in cars, in buildings, etc. So smart sensors, etc. So different types of devices, they vary also in price and in a lifetime. For example, for building automation, those embedded systems, they should stay there for, let's say, 30 years. But if you think of your smartphone, maybe after 2 or 3 years, I want to have a new one. For big supercomputers, every, I'd say, 5 years, you want to install a new one. This is not only because of the performance, but also because of the energy consumption. So how efficient are those systems? Okay, so we have the end systems. Then talked about already those intermediate systems. These are nodes, so some components interconnecting networks. on all different layers, as we will learn. So bridging, for example, a wireless network with a wired network, or a intercontinental fiber optics big high performance network with some local networks, whatever. So for intermediate nodes, you also have many different systems. Maybe you all know from your home, your apartment, a DSL router. So very, very, very simple system compared to the internet core routers on the right hand side. So this is a home router. We will learn in some more detail what routers are for, on which layer they operate, what they do, and basically you connect them to your DSL, so copper wires, the classical old phone lines, and this brings the internet to your home, or you connect it to fiber optics, or you connect it to a cable from cable TV, etc. And this router somehow managed to translate whatever comes in into some wireless signals, and then you have your Wi-Fi 6, Wi-Fi 5, whatever system. So quite cheap, 100 euros, whatever, lightweight, small system, and the data rate roughly gigabit per second, something like this. On the right hand side, you see an example for an internet core router. Well, it's one of these huge frames with computers in there, and yeah, a bit more expensive, and the data rates are also quite high. So this is rather in the range of terabits per second. Okay, so these are the components you need to connect end systems. And in between the intermediate nodes and the end systems, you will have the links. Links come in very different types, like fiber optics, like long range microwave connections, like Wi-Fi systems, etc. So it depends on the usage, it depends on the distance they have to bridge, it depends on the capacity, what type of link you can use. So you see in many places optical connections. So in the end, the optics are in here. So very, very, very tiny, small fibers. It's rather like a human hair. And this is where you send through the light. Light, infrared light, different wavelengths. You can send different wavelengths at the same time. It's called wavelength division multiplexing. And you have many of these small fibers, and they are protected because, well, you can easily break them, and you bring them together. So kind of a space multiplexing. You bring them all together in a larger cable, and this is what you see nowadays installed all over the place. So fibers. Also quite classical is copper wire. There you typically see pairs of wires, so not a single one. And as we are here in computer science, yes, I know I have to explain this. So typically, and we will touch this again in one of the following chapters, you need two wires. And quite often you ask people from computer science, so why two? Here in fiber optics, it's only one fiber. Well, here we have a current that flows. So that flows, and for a current to flow, it's not enough to have a single wire, because it has to flow in a circle from A to B and back to A. So this is why we need the two copper wires. So, and why they are twisted, I will explain in one of the following chapters. So twisted copper wires, and sometimes they are shielded, so you have an aluminum foil around this to protect from interference from the outside and also from the other twisted pairs. And then the lowest one, wireless. You see here examples for wireless antenna, and they typically then connect to the cellular phone on the road. You see also these are the round dishes here. These are microwave links connecting maybe to another base station. So this is a part antenna system from a typical mobile phone base station. You see them all around the place. So there are thousands of them. Although we see a trend towards wireless systems, so on a typical campus you have hundreds or thousands of hotspots installed, so wireless LAN hotspots, and we have tens of thousands of base stations in a country. And you may think, those wireless systems, they offer already many megabits per second, gigabits per second, and even some with terabits per second. Do we need wires at all? Well, yes. So you can watch a video explaining a bit more about this. We need many undersea cables, so this cannot be handled by wireless links, not by satellite links or microwave links or whatever. So the Earth is not flat, so it's a sphere. So we cannot simply send whatever we like just in a straight line. So in wireless communication, I will touch this in this other course. So, but really to interconnect countries, continents, we need many undersea cables. And they basically power the internet. That's really the backbone. Yeah, we have some satellite in addition, etc. So, but this is where we have to rely on. But these are cables. And from time to time, things happen to cable. And you may think that usually nothing happens. But for example, during conflicts between states, some states, they simply cut cables. Or someone who wants to destroy things, they simply cut something. And if you have a closer look here, you see, okay, that doesn't look nice. Or here, someone really cut off many of the cables. So it's not that difficult to find out where the cables are. And this has a huge impact. So you can easily cut off a country if you know where the undersea cables come to land. And so there you really have a big problem. There are some protections, etc., but we have many cases where a cable cut was confirmed, and these are not only attacks by someone, but maybe someone just digs a trench and then, oops, oh, there's something, there's a wire, what is this? I don't care. Breaks it, destroys it, and then suddenly whatever compute center cannot work anymore. So these are really big problems. And this infrastructure, if you saw or remember the picture of this fiber optics, this looks clean, nice, high speed, whatever. But the world is not always clean and nice and high speed. For example, here you see pictures showing how people sometimes are connected to networks, the telephone network, the internet, if you use a modem, for example. And there you really see, and here, for example, some years ago from Berlin, you see the very old telephone lines. The dozens of years here in the ground, rusty, whatever. These are classical telephone lines, some newer cables, and this is all being replaced by fiber optics, but not in all countries. And if you look at the left-hand side, you can imagine where problems are if you think of, okay, internet availability all around the world. So this is why in many countries, wireless connections are, well, basically the way to go, because replacing this, etc., it's way too complicated. Okay, so these are our components. We have the links, we have the end systems, and we have intermediate nodes. So what is the simplest form of a network? Well, basically two nodes. Two nodes connected by a wire or wireless link, that doesn't matter here. They form a network. So that's the simplest form. And here we already have to think of, well, if this is a single fiber or a twisted pair copper wire, how do we share this? How do we access this? And this is already a simple, small network where you access data on the other machine. How do we do this? How do we, for example, address the other machine? Oh, that's simple in the case of two computers. So if I send something here on this wire, well, okay, this will sooner or later end up here. Well, sooner or later, speed of light or 2/3 speed of light. And if this computer on the right-hand side sends something, this will sooner or later end up here. But look at this simple example here. If we send something on this wire, well, does it go to both computers, for example? Yeah, that would be quite simple. Uh, is this a good strategy for larger networks? Some more nodes make it a bit more complicated. But there are very simple systems. Think of a car where maybe it's fine to have this type of networks. If you send something on the wire, it will end at all the connected end systems. And then the end systems basically select if data is really addressed to them or not. Think of a World Wide Web network, that's not a good idea. So, although those examples are quite simple, these are already examples for, remote access on data from the other computer, on special functions, maybe on resources. And we will discuss how we address them, how we transport them, what are the formats for the transport, etc. So, for all types of remote communication, no matter how far remote is, maybe it's only 1 meter, we need some kind of a network. Or is it 10,000s of kilometers if you communicate with the moon? That doesn't matter, we need a network. Some simple questions for you. So, have a look in the internet and find out who really owns those large worldwide networks, and who is installing new large fiber optic networks. And there, maybe you find out something quite interesting, that maybe this has changed over the years. And if you own the fiber, the huge network, you also can control, at least to a certain extent, who will have access to the network, what kind of data is transferred. So we will discuss this, what the problems there might be. So fiber optics, as I said, I will dig into this in some more detail in a later chapter, but maybe you know already what are the big advantages. Why do we go fiber all over the place, although maybe we have a wireless connection or copper wire? But maybe there are also some reasons still using copper. Think of what do you use at home? Copper, fiber, wireless. And talking about wireless, we quite often see also the announcements, hey, that's marketing. We have here many gigabits per second wireless link, and that's cool, and we have high data rates, it grows and grows and grows. But why do we still use cables to connecting for connection of computer centers, for example? On the other hand, what are typical threats to cables? So maybe different types of threats compared to a wireless network.